Welcome to Khetz Tutorials, and in this video I'll be doing question 35 from A exercises in James Stewart Calculus. So this is the question. You asked to solve the inequality, then draw the solution on a number line. So this is what we have. One way to interpret this is you're going to look at places where the graph of x cubed, which should look something like this, is greater than the graph of x, which should look something like that. So it passes through the origin. So with this, you'd need to find the points of intersections where these basically intersect, so that you use that to find your intervals. And as you can see, this yellow graph is actually greater than x here in this portion, right? So that'll basically be your answer, and somewhere else as you proceed from there going up. But as I said, with this, you need to find intercepts, and there's a lot more work that is required if you're to follow that approach. In an exam situation, you'll want a quick method which you can use to find the answer. And that's what we're going to do. And here's how you do that. So you're going to take your x to the left-hand side, and that is the result. Factorize as far as you can. In this case, you can only factor out that. And this is what we have. You can now convert this into a difference of squares, which should look something like that. From here, just like we did in the previous questions where we had quadratic functions, we can also find critical values here. So let's draw the number line with our critical values. So if you were to solve this, your roots or your critical values would basically be 0. So if you put a 0 there, that becomes 0. So 0. Another one would be 1, which is somewhere there. Another would be -1. And we're going to do the exact same thing which we did in the previous questions. We're just going to pick a number which is to the left of -1, let's say -2. And if you substitute it in here, you're going to have -2, -2 minus 1, -3, -2 plus 1 minus 1. And if you multiply these, you're going to get a negative answer, as you can see. So multiplying these two will give a positive answer. Then multiplied again by a negative answer, we give a negative in this region. So for x less than -1, you have negative values going this direction. But remember, we're looking for places where this is greater than 0, where we have positive answers. Then next, we're going to pick the next portion, which is this portion between 0 and -1. So let's look at what happens there. Let's choose negative or half. So if we choose negative or half, you're going to have negative or half there. Negative or half minus 1 would be -3/2, or -1.5. And then we have negative or halves, 1 minus negative or half, or 1 minus a half, would basically give you a half. These give a positive answer. Multiplied by that, should also give you a positive answer. So in that region, in that section, we have a positive answer. Then moving on to this next portion between 0 and 1, we can also pick half, but the positive half in this case. So we're going to have half minus 1 here, which would be negative, and a half plus 1 would be +3/2. If you multiply all of these, you get a negative answer. So in this section, we have negative answers. And finally, we're going to evaluate numbers which are greater than 1. So let's pick 2, which is the nearest one. So we pick 2 and substitute in there. We're going to have 2. 2 minus 1 is 1. 2 plus 1 is 3. Then, as you can see, if you multiply these, you're going to have a positive answer. And now we're going to answer the question. We're going to check which regions or which sections have values which are greater than 0, or which are positive. And as you can see, that is this region and that region. To give your answer, you can either give it like this. So you have your answer here, or here, which is x greater than 1. So these are the regions between -1 and 0. And we're going to draw that like this, as well as everything which is greater than 1. So these are our answers, and this is how you'd plot it on the number line. Another way to write this would be x is an element of -1 to 0 union x to also from 1 to infinity. So these are the two ways that you can write your answers. But at the end of the day, we'll still use the same method where we just basically evaluated critical values and found regions which satisfy what the question was asking for.